Section: Introduction. In this section, we tackle the challenge of evaluating generative language models. It's tough to find suitable data to test these models and even harder to assess the accuracy of the generated responses. Multiple-choice datasets like MMLU have gained popularity because they make evaluation easier. However, multiple-choice questions focus on different aspects compared to free-form generative tasks, which are more relevant to real-world applications. Various metrics like BLEU, Rouge, normalized exact match, M, and token level F1 have been used for evaluation, but they often fall short in capturing the desired properties. QA metrics, for instance, can result in false positives and false negatives due to limitations in the reference answers. Recent approaches have tried using trained or prompted models for evaluation, showing better correlation with human judgments than traditional metrics like EM. However, these evaluator models, especially large ones like GPT-4, have their biases and tend to favor their own outputs. Moreover, using such large models as evaluators is slow and expensive, limiting their practicality. In our study, we conduct experiments across different settings and datasets to address these challenges. We suggest evaluating language model generations using a panel of LLM evaluators, POL, from various model families instead of relying on a single large judge like GPT-4. Our results show that using POL aligns better with human judgments and is more cost-effective. In some cases, GPT-4 may not be a reliable judge, showing high variability with minor prompt changes. By aggregating judgments from a diverse panel of evaluator models, we can reduce intra-model scoring biases. We delve into different scoring methods, such as single-point scoring, reference-based scoring, and pair-wise scoring, to evaluate model outputs. Instead of depending on a single judge prone to biases, we propose using a panel of evaluators to provide a more robust assessment. This pooling technique helps mitigate variations in judgments and errors, similar to how human annotations are normalized. Each evaluator in the panel independently scores a model output, and their scores are combined using a voting function to determine the final poll score. Section Summary. In this section, we delve into the challenges of evaluating generative language models, highlighting the limitations of traditional metrics like BLEU and Rouge. We propose a novel approach using a panel of LLM evaluators, POL, drawn from different model families to overcome biases and improve correlation with human judgments. By pooling judgments from diverse evaluator models, we achieve more reliable and cost-effective evaluations compared to relying on a single large judge like GPT-4, especially in scenarios where GPT-4 exhibits high variance or bias. Section: Poll composition and voting. In this section, we created a pool of logically linked poll composition by combining models from different families such as Command R, Haiku, and GPT 3.5. We used two types of voting methods to combine scores from the judges: max voting for QA datasets where judgments are binary, correct or incorrect, and average pooling for Chatbot Arena where judgments are scores ranging from 1 to 5 and a clear majority decision is often not reached with 3 judges. We included models from various families like Command R, GPT, Claude 3, and Mistral in our poll. For single-hop question answering tasks, models were required to retrieve evidence and generate answers based on questions. We conducted experiments on datasets like Natural Questions, Trivia QA, and Hotpot QA. In multi-hop question answering, models had to perform multiple rounds of retrieval to answer questions effectively. We tested this on datasets like Bamboogle and Hotpot QA. Chatbot Arena served as a benchmark for evaluating model performance in generating responses. We used a subset of challenging prompts and an automatic evaluation method involving judges like GPT-4 to score model outputs. Human judgments from Chatbot Arena were considered as the ground truth for evaluating model performance. To prompt the judge models appropriately, we used reference-based scoring and provided examples of valid and invalid question-answer pairs. We also included the exact match metric for reference in our QA experiments. Human reference judgments were collected using Cohere's annotation workforce. Cohen's kappa correlation was used to measure the agreement between different evaluator judges and human judgments. A strong correlation is indicated by a kappa value greater than 0.8, while a moderate correlation is above 0.6. Our poll showed the strongest correlation across various tasks, while GPT-4 performed relatively weaker on this specific task setup. Section Summary. In this section, we construct a pool of log likelihoods, poll, using models from different families like Command R, Haiku, and GPT 3.5, and employ different voting functions based on the dataset type, max voting for QA datasets and average pooling for Chatbot Arena. We evaluate the models on single-hop and multi-hop question-answering tasks, as well as on Chatbot Arena Hard, comparing their performance against human judgments using Cohen's kappa correlation, where poll shows the strongest correlation across various tasks. Section. Rank correlation on Chatbot Arena. In this section, we examine the correlation of different judge model rankings with human judgment on Chatbot Arena. We consider the ELO rankings from Chatbot Arena as the ground truth. By calculating Kendall-Tau and Pearson correlation, we compare the rankings produced by each judge method with this ground truth ranking. We observe that poll shows the strongest correlation with the gold rankings, especially at the top of the list. We then explore how GPT-4, despite being a powerful judge model, performed poorly on our KILT evaluations. We investigate how GPT-4 reacts to changes in its prompt. By providing in-context examples and instructing the model not to overthink, we see an improvement in performance. These changes bring GPT-4's agreement level closer to GPT 3.5, although still below Command R, Haiku, and poll. Next, we discuss the importance of reducing bias in evaluation by using a panel of diverse models instead of a single judge. By comparing the accuracy scores of individual judges and poll with human annotators across different datasets, we observe that poll has the smallest spread in scores, indicating higher consistency. GPT 3.5, on the other hand, shows the highest spread in scores. Furthermore, we analyze the model rankings on Chatbot Arena Hard by poll and GPT-4. Poll rankings demonstrate better correlation with the ground truth rankings, especially at the top of the list. Lastly, we consider the cost and latency of running poll compared to GPT-4 Turbo. Running poll is significantly less expensive than running a single GPT-4 judge. Additionally, running a collection of smaller models in parallel, as in poll, is generally faster than using a single large model.